Okay, in this video I will show you how to use Matlab to plot um, signals in time domain, and also the transfer function response, the frequency response of a transfer function. Okay, so these are the examples. We will have 4 examples here. The first one, yt equals to e80. This is the second one. The first one is in time domain. The second one is in s domain or frequency domain. So this is the transfer function. And then the third example, this example is taken from a book. So we will try to plot the Vi here, which is from this terminal to this terminal, right? That's the voltage. Now this is the voltage in time domain, so we will try to plot this signal. And also finally, the fourth example, we will try to plot, all right, the transfer function of this circuit, V out over V over I in. This is the circuit, so V out over I in of the circuit is this. The answer is already given, but we will try to plot the transfer function, the frequency response of this transfer function. So we will start off with the simple example, right? So here, this is the Matlab. I'm using Matlab R2017B. Okay, so we have here the command window, we have the editor. So I will use the editor to write down all the codes and then click run. So the Matlab will run all the codes and plot the signal. So what we have here, let's look back to the equation yt equals to e80. Right, so that's quite easy actually. Now y 2 times e exponential, right? Exponential, and the value of the exponential must be in bracket. So what's the value? 8 times t. All right, so that's the equation. So we write this down, and since in this equation we have t, so we have to declare t before we use this equation. So we have to declare what is t in before this line. So t is really depends on what you want to display, what you want to show in the plot. So at the moment, let's try with from 0 second to 10 second, right? So here 0 to 10 second, that is actually, if you want to see, that is will show you from 0 to 10, incremental by 1, 0 1 2 3 4 5, so on. Okay, that's how you use that function, that command. All right, so now we have declared what is t, and so this value will be included here, right? And then we'll calculate y. So we have the complete equation now. So we want to plot the signal. So first is the x-axis, next is the y-axis, right? Basically, and I always put clear all in the beginning of the command. So let's try to run. Okay, desktop, save, untitled. Okay, Okay, so this is the signal of this equation of y, but it looks not the best way to display this exponential plot. So actually we will try to change um, the x-axis. Alright, actually let's try here. I already know what's the best one to plot, but in your case you have to try around. Right, now before I do that, let me show you. Now if you use this, okay, you enter 0 to 10, you get that 0 to 10, but in between you key in 0.5. what happens is that the incremental is 0.5. you see, now incremental is 0.5, so 0, 0.5, 1, 1.5, 2.0. so it's like that. So if you do that, you can get to plot the signal more accurately. Okay, I'm going to show you the final one, which can give you probably the best plot, right? So it's from negative 0.25, incremental 0.001 to 0.25. Let's look at the result. So that is the plot for the same equation, for the same y equation, and here this looks much better, and we know that the front value, this is 2, means that it is crossing at 2 at y-axis, so 0, this is 2, right, crossing at 2, and it's a positive exponential, so it's a positive exponential, right. So this is how you plot the signal.